Question 3, I'm given a triangle with the vertices A, B, and C and their coordinates, and I'm told that AD is a line in the triangle such that D is the midpoint of B and C. So that means that this line BD is equal in length to this line BC as labeled, and I'm told the coordinates of D are negative 2k, so I know the x value, but I don't know the y value of D. Then we can answer the questions. So the first one, 3.1, asks us to determine the gradient of BC. So the gradient of BC, MBC, is equal to rise over run, which is the change in the y value over the change in the x value. So I'm going to have the y value of B minus the y value of C divided by the x value of B minus the x value of C. The y value of B is 2 and of C is 6, divided by the x value of B is negative 8, minus the x value of C is 4, and then I will have negative 4 over negative 12, and that is a third. Then 3.2 asks me to calculate the length of BC. So for the length, I can just use the distance formula. So I'm going to say the distance, BC, is equal to the square root. And it's the x value of the one minus the x value of the other one squared, plus the y value of the one minus the y value of the other one squared. And since I was given the coordinates of B and C, I can just substitute those values into my equation. So I'm going to have the x value of B, which is negative 8, minus the x value of C, which is 4, all squared, plus the y value of B, which is 2, minus the y value of C, which is 6, all squared. And when I solve that, I get 4 root 10 units, because we're talking about distance. Then 3.3 says to determine the value of K. So remember, we were told that K is the y value of the point D, and D is the midpoint of B and C. So if D is the midpoint of B and C, then that means that the x value is halfway between these two x values, and the y value is going to be halfway between these y values. And so I'm just going to use the midpoint formula. So I know that D has the coordinates minus 2, K is what I'm trying to find out, and the D is the midpoint of BC. And so for the x coordinate of the midpoint, I've got the x coordinate of B, which is negative 8, plus the x coordinate of C, which is 4, and that's going to be divided by 2. And then for the y coordinate of the midpoint, I have the y coordinate of B plus the y coordinate of C, also divided by 2. So for the x coordinate, I get negative 8 plus 4 is negative 4, divided by 2 is negative 2, which is exactly what I expected because I already knew the x coordinate for D, which is the midpoint. And then for y, I'm going to have 2 plus 6, which is 8, divided by 2, which is 4. And therefore, that means the y value of D, which is equal to K, is equal to 4. Then for 3.4, we're asked if AD and BC are perpendicular to each other. So I know that two straight lines will be perpendicular if the product of their gradients is equal to negative 1. Right, so if it's true that AD is perpendicular to BC, then the gradient of AD multiplied by the gradient of BC must be equal to negative 1. So I already found the gradient BC in part 3.1, and that was a third. And now I can find the gradient of AD. In the exact same way, the gradient of AD is going to be the change in y over the change in x. So I'm going to have the y value of A minus the y value of D divided by the x value of a minus the x value of d. So I'll have y of a minus yd divided by x of a minus xd. Then I know the coordinates of a and d, so I can just substitute in these values. So y of a I was given is 7, and y of d we just found to be 4. Then the x of a is negative 3 we were given, and that is minus the x of d, which is minus 2. So this minus minus 2 is going to become plus 2. And I'm going to have 7 minus 4, which is 3, divided by negative 3 plus 2, which is negative 1, and that is equal to negative 3. Right, then I'm going to say MAD times MBC is equal to negative 3 times 1 over 3, which is equal to negative 1. Therefore, AD is perpendicular to BC. Gauteng, November 2022, Maths Grade 10, Paper 2, Question 8. I'm given this parallelogram PQRS, that is this one, and I'm told that PW bisects this angle QPS. So if this is bisected, then that means that this angle is equal to this angle. And I'm also told that SW, this line, bisects PSR, that is this angle. So that means that this angle and this angle are equal in size. And I am told that PW is parallel to ST and that PT is parallel to WS. Right, so the first question asked me to prove that x plus y is equal to 90 degrees. So immediately from the fact that these angles were bisected, I can say that, for example, angle P1 is equal to angle P2, and that angle S1 is equal to angle S2. So I'm going to first say that P2 equals P1 equals x, and that's given, and S1 equals S2 equals y, and that's given. And then I was told that PQ, this shape, this PQRS is a parallelogram, and so that means that PQ is parallel to SR, and PS is parallel to QR. So, for example, if these two are parallel, this PQ and this SR, then I'll have that co-interior angles add up to 180 degrees. So that means that this angle here plus this angle here is going to equal 180 degrees. So I'm going to have P1 plus P2 plus S1 plus S2 is equal to 180 degrees. But I just found out that the P1 is equal to the P2 and it's equal to x, and that the S1 is equal to the S2 is equal to y. So that means that x plus y is equal to 180 degrees, and that's because of co-interior angles of these parallel lines. So x plus y equals 180 degrees. Coint angles. And PQ parallel SR, and I'm just adding up like terms, so 2x plus 2y equals 180 degrees, and I can divide everything by 2, so x plus y is equal to 90 degrees. Then the next question, I'm asked to prove that PW ST is a rectangle. So I already know that PWST is a parallelogram because the opposite sides are parallel. And so to prove that it's a rectangle, I just have to prove that one of these angles are 90 degrees. Okay, and I'm going to use the fact that in the previous question I found that x plus y is equal to 90 degrees. So I know that P2 is also x and that S1 is y, I was told that. And if I look in this triangle here, I know that the sum of these angles must equal to 180 degrees, like is in every triangle, which means that this x plus y plus w1 must equal 180. But I already found that x plus y is equal to 90, which means that 90 plus w1 must equal 180. So therefore w1 is 90 degrees. And so if I've proved that w1 is 90 degrees, then I've proved that one of the angles in this parallelogram is a right angle, and that's enough to prove that the parallelogram is a rectangle. So I'm going to start with, I've already said P2 is equal to x in the first question, so I'm just going to go straight in and say that P2 plus S1 plus W1 must equal 180 degrees, and that is angles in triangle PWS, and I'm replacing the P2 and the S1 with x and y, so P2 is x, S1 is y, W1 180 degrees, and since I've proved that this x plus y is equal to 90, I can just say that W1 equals 90 degrees. Right, then I say that PWST is palm, and I can say two up sides parallel, and therefore PWST is a rectangle and that is because W1 is 90 degrees and PWST is palm. Question 9, we're given a parallelogram ABCD and we're told that AD is parallel to BC and BA is parallel excuse me, to CD, as we would expect. And using the diagram above, we want to prove the theorem that states that the opposite sides of a parallelogram are equal. So I can do this by proving congruent triangles because, first of all, I've got this common line DB. So I'm looking at two triangles. It's going to be BAD and BDC. So I can first say that this BD is common. Then I have the parallel lines from the parallelogram. Remember, I was told that this ABCD is a parallelogram, and I was told about the parallel sides. So I can use the parallel sides. The only thing that I can't use is the equal sides because that's what I'm trying to prove. So I'm told these parallel sides, which means that I can use my alternate angles. So if I've got these two parallel lines, AD and BC, then that means that this angle is going to be equal to this angle from alternate angles. And similarly, from these parallel lines, I can say that this angle is going to be equal to this angle. Then I've got two angles and one side. And so I can say that the triangles are congruent. Now, if the triangles are congruent, that means that this line is equal to this line, and this line is equal to this line in length. And then from that, I can prove that the opposite sides of the palm are equal. So I'm going to start by saying in triangle ABD and triangle DBC, BD is common. Then I want the alternate angles, so I'm going to start with the B2 and the D1. So I can say that angle B2 is equal to angle D1, and that's because of alt angles, where AD is parallel to BC. And similarly, angle B1 equals angle D2, alt angles, and now the parallel lines I'm talking about are the AB and the DC. Right, therefore triangle ABD is congruent to triangle DBC, and that is from side angle. Okay, then next, if I have the congruent triangles, I can say that the relevant sides are equal. So for example, the AB is going to be equal to the DC in length, and the AD is equal to the BC in length. So BC equals AD, and that's because of congruent triangles. And AB equals DC, also congruent triangles. Therefore, upsides of palm A, B, C, D are equal. Question 10, I'm given this triangle ABC, and I'm told that D and E are midpoints of the sides AB and BC. So this one is a midpoint, and this one is a midpoint, and immediately I'm told midpoint, I'm thinking midpoint theorem. All right, and then I'm told that point P, which is this one, is a point on BC such that PA is equal in length to PB. So these two are equal in length. And PB cuts DE at R. Okay, and then prove that RDB is isosceles. This is RDB. So if I want to prove it's isosceles, I'm either going to prove that these angles are equal to each other, or that this RD is equal in length to BR. So first of all, I've got these midpoints D and E on two opposite sides of a triangle, and they're being joined by this line DE. And from the midpoint theorem, I know that that means that DE is going to be parallel to AC. DE, midpoint theorem. Then when things are parallel, I'm always looking for my co-interior, alternate, or corresponding angles. And indeed, these two are parallel. And then there's this line here, this AB. So that means that this angle is going to be equal in size to this angle, and that's corresponding angles because of the parallel lines AC and DE. So angle A is equal to this angle D2. D2 corresponding angles AC parallel DE. Okay, so now I know that these are equal. All right, and then the question was asking me to prove that this triangle is the isosceles one. And now I know about the size of this angle that is equal to this one. So I'm going to try and get this angle equal to this one. Then I can say that since these two are the same, that this must be an isosceles triangle. So I go back to the information I was giving in the question, and I haven't used yet that this length PA is equal to the length PB. So if these two are equal in length, then it means that this APB is an isosceles triangle, And in an isosceles triangle, the angles that are underneath the equal opposite sides are going to be equal in length as well. So that means that this angle A is going to be equal to this angle B1. So I'm going to start by saying that triangle APB is isos. And that's because PA equals PB. Then I can say that angle A is equal to angle B1, and that is up angles in isos triangle APB. Alright, so B1 is now equal to angle A, and now I can see that if angle A was equal to angle D2, and if angle A was equal to angle B1, then angle D2 is equal to angle D1, and I have my isosceles triangle in DBR. So I'm going to say therefore angle B1 equals angle D2, and therefore DRB, triangle DRB, is isos, and that's because of opposite angles being equal.